Problem 31, we've got a base runner running from second base to third base, and in baseball, the distance between all the bases is 90 feet. And so at some point as they're running from second to third, I define P as the distance that base runner is from third base at any point in time, and S as the distance from the runner to home plate. I don't really know why we need that distance. It's not like the catcher is going to whip the ball at the runner. Baseball just doesn't simply work that way. But sometimes the real world and calculus don't always match up. We know the rate that the runner is running. That seems like a silly statement, but the rate of change of the runner, that's more elegant, is 25 feet per second. But because I define the distance to third as P, that rate would be negative. You can solve the problem differently. This is how I chose to do it. You could have defined the distance away from second base and gone the route of defining the distance that we're looking for as 90 minus that value. But I went with this. We're looking for dsdt when the player is 20 feet from third base. Once again, we've got a standard Pythagorean theorem problem. P squared plus 90 squared is equal to S squared. And again, the distance from third base to home never changes, and therefore we can put that constant in. Okay. Again, if a value never changes in the problem, you can put it into the initial problem. Derivative again. dp dt is equal to, derivative of 90 squared is 0, 2s ds dt. Okay, so we know dp dt. We know p. We're looking for ds dt. And as we've seen before, I'm going to need to do a sidebar because I'm missing a chunk of information, and the chunk of information I'm missing is how much S is. So at that snapshot in time, the player is 20 feet from third base, so P is 20. The distance from third to home stays constant, and that would give me the value of S. Solving this, I get a fairly ugly number of 10 square roots of 85. And again, if you want to use the decimal value there, you can. Just make sure you store it on your calculator, because you will need to have a final answer that is accurate to 3 decimal places. Okay, so plug and chug now. I get 2 times 20 times negative 25. And again, notice I'm putting that negative 25 in parentheses because we don't want it to be mistaken as a minus 25. 2 times 10 square roots of 85 times ds dt. Working some math magic there, we get ds dt is equal to negative 5.423. And then my units, S is measured in feet. Time is measured in seconds, and I get that as my final answer. Does that make sense? Well, I'm not so sure about the numerical value, but I am happy about the sign, because as that player gets closer to third base, the distance to home plate should be getting smaller, which would mean the rate of change would also be negative.